Hello friends, welcome to my YouTube channel Knowledge and Education Hub. As we had discussed in my previous video what is .nc or netcdf file, and in this lecture video I will show you how to extract information from .nc file format and how to convert .nc file format into image file and .csv file format with the help of R programming language. For this, first make a directory in RStudio. The code for the directory is setwd, and this is the line for the directory path. After this, install or download the following packages and run on RStudio: library R-star, cron package, rclr brewer package, lattice package, ncdf4 package, ncdump. ncdump and ncdf4 package is the package for to read the .nc file. Lattice package to use for make gridded file. rclr brewer package is to use for color. cron package is to use to extract the time information. raster is used to the for image construction. Next, set the path for the .nc file. Give the path from your directory. Here the name TWS. TWS in this in practical section I will show you the .nc grace data of the .nc file, and the variable of the grace data is a TWS, which is a total storage water anomaly. That is the variable. You can give you can take the any name, but the variable is the TWS. Is the for simplicity take the name is TWS. Okay, now gives the nc frame name, paste name, nc name, format is a .nc and separable is a comma. Now for the get information of the .nc file, when you use this command raster tws.nc, that is your file name, gives you the entire information, how many bands are there in your file, and what is the source of the file and what is the resolution of your file, etc. We will see in the practical part. After then, get longitude and latitude part. For this command is this. Okay, we will see also this. We will see in practical part. In this section, we will see the time dimension of the data file. The code are this. Now in this section, we will extract the all information of the .nc file and arrange these information in array and matrix format. For this is a command for the array, in which the our file is arranged, and finally take the dimension of array and give the institution, data source, reference, history and convention. These are the information of the .nc file, where this file were taken and what is the website of this file, etc, etc. Okay, we will see in the practical part. Finally then close and give the list of this. Now get dimension information and split the time units in the fields. Now these files are split into time units. First title value and close library, use the already I have installed and run on the RStudio. Then this is the split command for the time. Now in this section we will convert the .nc file to the image file. Array we have arranged. Now this array image and these array are converted in a slices form. There are 3 slices. One is the latitude, longitude, m is the time dimension, and after then the make a grid file. grid is the very important to make plot the image file, because grid is take the value of the data, define the value, define the extension of the data. After then level plot. Okay, in this section we will convert the .nc file into CSV file. Same format, expand the right grid, and in this grid give the information of latitude, longitude. After then make a file in which the all latitude and longitude in a data frame comes to in a data frame. Then paste this file and give the command header command. Header commands is the command for to take the value of the first 5 value. Here be 20, then take the first 20 value of the data set and give the CSV file name. Here I will give this RGS file. Okay, finally this is the code for the write CSV file, CSV file in our directory. Okay, now come to the if you have any query, then you can inbox me at my email ID. Now let's come to the practical part on our platform. Okay, first make the directory. For this I will make a directory rgis. In this my data file tws.ns as given. Actually this file I have named the tws because I have already told you why I give this name, because the variable name is tws. It is simplicity for me. You can take any name or take the original name. The name is the very big, and in write-up part it may be some mistake, or maybe some mistakes have come. Then you can take a very short name. Here I will take the tws. Tws is a variable part and very short for my convenience. Okay, run the set directory path. Directory has made. Now run these packages: raster, cron, arcler, brewer, lattice, ncdf4, ncdump. Okay. Now create a path for our file which are contained in directory. Okay, and name is the tws. Now come the frame, its value fetch in the frame. Okay, now dpt raster. Dpt is my file name. Okay, here gives the information of the .nc file. That is, class is the raster layer. There are 7 bands, which means that these are in the monthly data, and for the year 2002 these data are recorded for the 7 months. Dimension is this: 180 degree to 360 degree and 64 row, column and cell. There are 64,800 cells. Resolution is 1 degree to 1 degree. Extent this. Projection is this. Source is this. That is my directory file. Names gravity based terrestrial storage. Z value is that is a year. And Z barrier is TWS. This is the very important to select the name, which we'll use in further code. Okay, next is now this gives the entire information of the data file. There are 3 variables: double tiff, longitude, latitude and time, standard name, terrestrial water storage, error factor is also given, double error factor, dimension is time dimension, size 7, it means 7 months are given, and it is for the year 2002. Longitude and latitude information as given, global attributes, that is CD climate data interface version, convention, and this is the information of the source. Okay, next come to the latitude and longitude information. Okay, add on latitude, longitude, that is the 5 value of the first 5 value of the longitude. Similarly for latitude, add up the latitude, first 5 value of the latitude. Now come to the time value. Okay, now dimension is a 7, it shows the 7 there are 7 months data are contained in that content for the 2000 for the year 2002. Now select the name. Dname is very important because the variable name is TWS. For different NC file must gives a variable name, which will I have to give here. Okay, array name. Now these NCIN and dname which have already run on RStudio, and these two codes fetch into array format. Okay, dimension of the array is 360, 180 and 7. These are latitude, longitude and time. Now come to the institution title. What is the title of this NC file? Globally graded continental water storage anomaly. These data are graded data. Okay, now come to the institution. Okay, and gives the information of the institute. Section Earth system modeling. Institution, data source. Data source I have not run. Okay, data source, monthly data, grace level, product 2, trend, and these are the data source data reference. What is the data reference? Data reference is to value and error value. Now data history. Value and this history is to false and true. Conventions. What is a convention in this file? CF 1.6, which I have already seen. Okay, now the list part. How many lists are given? Convention, data source, DL name, dname, dpt, dunits. These are the lists are used in this code. Title value. We will the title value. First extract the title value. I will show you. Title value and HASST used for the extract the error factor, and this is the value factor. What is the real value of the data and what is the error factor in that data, which will do from the HSST. That is second one. Okay, first we will do this, and similar pattern we will do for the error factor. Okay, globally graded continental water storage anomaly. That is now split in these data in a time units. First is day, since it is recorded from the 18 March 2002, March 2002. Month is 4 month, and month is 4, days are 18. That is the recorded time of the data, that is started from the data recording 18, and this data is recorded from the 18 March 2002 for the year 2002. Okay, now next is the cron time, how much data contained in this file. This is the cron time. Time is taken to 2002, 18 March 2002, 9 May 2002, 16 August and September, October, November and December. This is the time unit for the data, exact time of the data for the month, this month, this month, this month. Okay, next is the length of the data, and in which for this command omit the NA value, not available value, after containing the matrix format. Then it is making a slice. Here the one is latitude, longitude, and M is the matrix format that is here we have defined, and which the time factors are given. Now make the grid for grid for latitude and longitude. This is this command for the grid. Now take the grid value. Now see the grid value. This is the grid value for latitude and longitude. How many grids are made? You can see here 64,300 grids have made. Okay, now comes to the level plot. And this section, the .nc file converted into the image file format. Okay, it will come, just come. From this you will take these value as a tiff format, as a meta file format, or PNG, JPG. There are many formats are given. Generally tiff formats are used for remote sensing purpose. Okay, the .nc file has converted into image format. Now next step, how to .nc file convert into CSV file format. Okay, level plots has done. Now expand the gridded long latitude and longitude. Okay, the grids are expanded. Same grid is 6,300 grids have made. Now these grids are convert in vector format. Now length of this vector. Now make all grids vector of the grids in a one data frame. That's name is the RGS1. Okay, now paste RGS1 in this. Now take the first these are the combined form of the all 7 months data, in which the annual average of the data for the 7 months. For further you can also split separately. You can take the separately this data, monthly wise data, but here I will show you the average of the annual data for the 7 months. Okay, this gives the head command. This gives the first 20 of the data file. Okay, and this is the first 20 value of the data file. Latitude, longitude, latitude, and TWS, total storage anomaly value. This, and these are in the centimeters. The Unit of this value is the centimeter, which have seen in the first part of the in beginning part of the program. Okay, now give the CSV file name is rgs.csv. Okay, take this file in directory. For this command, any table file, this file to take in CSV format, and this command is used. It means the any omit, it means not available value has extracted, that is a filter part value. And for similar fashion we'll use for error factor of the this file, this .nc file. Okay, come. Oh, that is okay, here run. Now come to the nc. This has saved here in the directory rgs. You can check this file in Excel format, that is the CSV format, from .nc to CSV, and from CSV you can easily convert this into text, ASCII format or others. That file is saved. You can also use this for this code for the separately 7 months. Okay, I hope this lecture video is very useful for to all. If useful, please like and subscribe. Thank you.